The topic of this lecture is wave equation. We'll cover one-dimensional wave equation in this lecture. We'll find the solution. So let us see the problem. Find the solution of one-dimensional wave equation using separation of variable method. So for this, consider one-dimensional wave equation which is given by this, subject to the condition where x lies in this interval and t is greater than 0, subject to the condition which are called the boundary condition. This is the first condition, that is u at 0 comma t is 0 and u at l comma t is equal to 0, where t is greater than 0. These two are the conditions given. Now let us suppose that the solution of our equation, let us suppose that the solution of this equation is of the form uxt is equal to xt into dt. So by using this equation, we obtain this equation very easily. How we will get this? It is because this is del 2 by del t square, and the value of u when we'll put, that is x depending on x and capital T depending on t. So that gives this x, because it is constant in this case, will come out, and this will become t double dash t, that is written here in this form over here. Similarly, from the right hand side, we'll get these values very easily. So this equation we have found. And from this equation, we get this equation by separating this x will take this side and t, all the expression containing t will come over here, and we'll suppose that this is equal to k, where k is nothing but separation constant. Now let us take case number 1. What will be the case number 1? If k is greater than 0. Then suppose k is equal to lambda square. Then what will happen? The first and the last, that will give this equation. And the second one and the last will give this equation. And we find the solution of these two. The solution of this will be this. The first one solution will be this, and the second one solution will be this. How will get this solution? That's very easy, because the auxiliary equation in this case will become m square minus lambda square is equal to 0, and that gives m is equal to plus minus lambda. And we know if this types of value of m comes, then solution is of this form. By same way, the second equation's solution will be of this form. So therefore, because we have supposed that ut is equal to of this form, so multiplying these two together, we get this equation. Next, now using the boundary condition. What is the boundary condition? u0t is equal to 0. We'll get c1 plus c2 into c3 e to the power c lambda t plus c4 e to the power minus c lambda t is equal to 0. Because we have to put the value x is equal to 0, because here x is equal to 0. So we'll put the value, let us see where to put the x is equal to 0. We'll put the value x is equal to 0 over here. So this gives c1 plus c2 and this complete expression, and this will be equal to 0 when we'll put this condition. So we are getting this condition. But if this equal to 0, then simply we'll get c1 plus c2 is equal to 0. So this first thing we obtained. Now using the condition ult is equal to 0, we'll get that this expression is equal to 0, because this value when we'll put over here in the equation, when we'll use the condition that ult is equal to 0, then here in place of x we are going to put the value capital L over here, and that will be equal to, all this expression will be 0. From this we'll get this expression is equal to 0. Now this 4 and 5 possess a non-trivial solution when these two equations will have a non-trivial solution when this expression holds. How this comes? Because you can see these two equation, this will have a non-trivial solution if the determinant of the coefficient 1, 1, here the coefficient will be e to the power lambda L, here the coefficient will be e to the power minus lambda L is equal to 0. This determinant should be 0. This gives e to the power minus lambda L plus e to the power lambda L is equal to 0, and taking e to the power minus lambda L common, will get e to the power minus lambda L is equal to 1 plus e to the power 2 times lambda L is equal to 0, and because this is never 0, so we obtain this equal to 0. So this value we have found over here, and from this we get this, and 1 is can be written as e to the power 0, so comparing the powers we get lambda L is equal to 0, but this implies lambda is equal to 0 because L is not equal to 0. But this is against our assumption that k is greater than 0, because we have got this lambda is equal to 0. But what is the value of k? K we have taken as a lambda square, and we have supposed k is greater than 0. So if lambda is equal to 0, we'll get k is equal to 0. But that is not true, because we have supposed k is greater than 0. So because of this, this solution is not acceptable. Now take the k is equal to 0. This is the second case. In this case, we'll get these two equations. How we are obtaining these two equations? From this, simply when lambda is equal to 0, first equation will get d2x by d small x square is equal to 0, and from here this equal to 0. So these two values will obtained, and when we'll solve this, you can easily solve this. How to solve this? d2x by dx square is equal to 0. So finding the first derivative integration, you will get dx by dx is equal to, say, some constant a, and when we will find the integration one more time, you will get capital X is equal to ax plus b. So this solution we'll find over here for this equation, and for this equation we'll find the solution this, and as u is equal to product of, we have supposed that this is the product of xx and dt, so we have got this solution in this case. Now using the boundary condition u0 t is equal to 0, so what we have to do, we have to put x is equal to 0 over here. We'll have to put x is equal to 0 over here, so we'll get simply from this b times this, and because this expression is not 0, so we get b is equal to 0. Now in this expression, note that we have obtained that b is equal to 0. So using this equation, the value of x is equal to L. So this is AL, Ct into D is equal to 0. This simply gives A is equal to 0. So what we are getting, A is equal to 0 and B is equal to 0, both are 0. So this whole expression will become 0. So this gives uxt is equal to 0, which is a trivial solution. So this lead to a trivial solution. Uxt is equal to 0, but we require a non-trivial solution. So we'll go for the now the case number third. Now in case number 3, when k is less than 0, let us suppose, so k we take as a minus lambda square where lambda is greater than 0, and we'll get simply, as we have seen in the last two cases, we'll get this equation, and from this the auxiliary equation for the first will be m square plus lambda square is equal to 0. This gives m is equal to plus minus lambda I, and from this we know if such a case, then solution is given by like this. Similarly for this equation, we'll get the solution this for t, and this is for x, and we know we have supposed that u is equal to x into t. So we got the this solution. Now here, using the boundary condition, what are the boundary condition? This is the boundary condition u0 t is equal to 0, that we have to put x is equal to 0. So x is equal to 0. So this will simply become 0. And then it will become cos 0 is 1. So C1 into all this expression will become 0. Which expression? This expression as it is. This gives C1 is equal to 0. So we have obtained this. Now by putting the second condition, ULT is equal to 0. So wherever x is coming, C1 is already 0. We also found this. Wherever the x is coming, this becomes then C2 sine Lx into the second expression as it is equal to 0. But C2 is not equal to 0. Why? Because C1 and C2 if both are 0, we'll again get the trivial solution. So we found that sine L, it should be lambda is equal to 0, which is written over here. From this, we get the lambda is equal to n pi by L. Because when sine is 0, if the value is n pi by L, this is the value. So, when we'll put these values, C1 we have already found it is 0, and the value of lambda we have found this. So, we'll put these values over here, and this C2 we are multiplying inside. So C2 and C3 will be multiplied, and C2 and C4 will be multiplied. So we get this expression where AN is C2 into C3 and BN is C2 into C4, and we get this expression. This is valid for all n. So by using the superposition principle, this will be true for if we take the summation of all these things. So finally, we got this expression, which is a non-trivial solution in this case. So thank you very much. You can find the link of the PPT in the description box. Thank you.